Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about graphing linear equations. And the first word problem we're going to start with is John is a mountain climber and is at the top of a 1,560-foot mountain. He can descend down the mountain at a rate of 75 feet per hour. Part A says write an equation to represent how high off the ground John will be after he has been climbing for any number of hours. So for part A, we need to define a couple variables here, and we're going to use f to equal the height of John off the ground. So that's going to be in measurement of feet. And then h is going to be the number of hours John has been climbing down the mountain. And then we can say that f then equals 1,560 minus 75h. So that would be our part A answer for the equation. Then for part B, if we want to create a graph to represent how high off the ground John will be, we're going to use the same kind of information, but now we're going to be creating a pictorial representation of what we're saying with the equation. So in this graph, we're going to create a vertical axis and a horizontal axis. Okay, so on the horizontal axis, we're going to go ahead and call that the number of hours. And then the vertical axis we're going to say is height. And we're going to say that's in feet. Okay. And there's several ways you can create the graph here. I'm going to look at probably two or three that are pretty most common. One of the most common ways to do this is you could probably start by saying, you know, we're looking at 1,560 feet. That's where he starts his climb at. So that's a good place to start your graph on the height column or the vertical axis. And if he's descending down the mountain at 75 feet per hour, well, we want to use 75 feet as our increment, or in other words, our scale for the vertical axis. So as we go down the mountain, we're going to decrease every line by 75 feet. And that would probably be the best use of the scale here for this problem. So as you go down the mountain, the next dash here would be 1,485 would be the second dash. Then the third dash would be 1,410. The next dash would be 1,335. Then you have 1260. Then you have 1185, and so on and so forth. You can keep going. I'm going to go ahead and just write in the rest. 1035, 960, 885, 810, and then 735. Okay, and then obviously we're not going to get down to 0 here, so what we're going to do instead of going all the way down to 0, we're just going to put a little squiggly mark. And that squiggly mark indicates that we're saying that we're not going to end up making it 0 with the scale that we have. So we can just zoom in on the line there. And really, if you wanted to, you could really erase these markings here on the right side of the axis and just leave the other ones there. So we've got an accurate scale here. And then since we're going down 75 feet on the vertical axis, that's for every hour on the horizontal axis. So each box now we're going to represent as 1 hour on the horizontal axis. So this would be 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6, 7, 8, 9, 10, 11, so on and so forth. So we're starting the climb at time 0, which is here. Before he ever does any climbing is at time 0, and he's at 1,560 feet. After 1 hour, he's gone down 75 feet, which would be 1,485 feet. And then he would continue down 75 feet every single hour as he goes down the mountain. And so that's what each of these dots is representing. Okay, and then we could just connect the dots with a line. And there's a nice straight line here. It's a good pattern. We call this a linear progression. So it's decreasing at a constant rate here. The constant rate is 75 feet per hour. So this would be one way to create the graph for part B. You could also change the scales here. You don't necessarily have to have every increment as being 1 hour. You could change this actually to every 2 hours. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, and so on and so forth. Okay, then what that would do is that would change how you draw these dots here. So let's just say we keep the vertical axis the same. That would mean in 2 hours we've descended 150 feet. So in 2 hours, down 150 feet, that would mean we'd be down here after 2 hours. And then after 4 hours, we'd be here. And then 6 hours, and then 8 hours, and so on and so forth. And you can continue that pattern. And again, you'll see a nice straight line here and a constant pattern. So, and then of course you could change the vertical axis if you wanted to. You could always change the number of feet you're going by. So let's say we changed just the vertical axis now. Leave the horizontal at 2 hours, every 2 hours. So you could say, I mean, you could do a lot of different things here. You could start at 1560, and you could go down by 150 every time. So you could, if you did that, you'd have 1410 here. You'd have 1260 here. You'd have 1110 here. And then 960 here. 810 here. 660 here. And then 510 and 360 and then 210 and then 60. So that would be going down 150 feet every box. And again, you can erase the right side of this. You don't necessarily need those on this side, so we can kind of skip a few boxes. But you can see, if I go down 2 boxes here on this axis, that's going down on the mountain 300 feet. So that I would travel 300 feet in 2 hours. So in 2 hours, traveling 300 feet, that would mean I'd have a box here, I'd have a box here, and then I'd have a box here. So with the current scale, we're saying, so every 150 feet that we travel down the mountain, so every 150 feet here we travel down the mountain, we're taking 2 hours to travel that distance. So our next dot would be here. Every 150 feet we go down the mountain, that's 2 hours here. So we just keep drawing boxes. Or we keep drawing arrows to go down and then over, down and over. And then our constant rate would look like this. And we just connect the dots with a solid line. And again, this would be our graph for part B, for the height of the mountain. Okay? And then we could use this if we wanted to. We could keep going all the way down to 0. We wouldn't have to. There's enough information here to determine all the information that we were given in the equation here, which was F equals 1,560 minus 75h. So the 1,560 is my starting point on the graph. So if I look at the graph, that was my starting point here on the graph. And then my 75h, so my 75 represented how many feet I was going down the mountain every hour. And that green is represented then by the rate of change, so the slope of the line. So every slope of the line here from dot to dot, that represents the 75 feet going down the mountain. And then every hour, so the number of hours here is the h. Okay, let's look at some practice problems for tonight's homework. So tonight for homework, you're going to be looking at this problem here. So Amy is saving her allowance for college. We need to reword that, actually. Okay, I went ahead and changed that for this problem. So it says this: Amy is saving her allowance for college. Her parents pay her $35 a week to clean the house and take out the trash. She already has $150 in her savings account. Part A, write an equation to represent how much money Amy will have in her savings account after any number of weeks. And then part B, create the graph to represent how much money she will have in her savings account after any number of weeks. So that would be the first problem for your homework. Number 2, the second problem is going to be hot tub problem. So the hot tub at your house can hold 450 gallons of water. To drain the tub, you must pull out the drain plug at the bottom. The water can only flow out of the drain plug at a rate of 7.6 gallons a minute. Part A, write an equation to represent how much water will be left in the hot tub after it has been draining for any number of minutes. Part B says, create a graph to represent how much water will be left in the hot tub after it has been draining for any number of minutes. So you're going to be using the same type of strategy we used for the practice problem for these two homework problems. So we will talk about this on Wednesday when you come into class. Thank you very much. Bye-bye.